Hi everyone, I'm Pratima. I welcome you all to my channel. I thank all the subscribers for subscribing and supporting. This is a IMO question. Consider an isosceles triangle. Let capital R be the radius of the circumscribed circle and small r is the radius of the inscribed circle. Prove that the distance d between the centers of those two circles d equals to square root r whole into r minus 2y small r. So here you can see two uh, figures. So one, this incenter is below the orthocenter, and for second one I is above the orthocenter. But whatever figure you do for this isosceles triangle, you will get these two situations. So here AB equals to AC, ABC is a triangle, and AB equals to AC. So when AB is equal to XC, certainly in the isosceles triangle O is your circumcenter, so OA equals to OB equals to OC equals to this bar, and I is in center. So here in isosceles triangle, I lies on particular bisector. BC. So OI equals to small d, and we have to prove d equals to square root of r into r minus 2i is inradius, or this is same as d square equals to r square minus 2r inradius. We have to reach here, or I can this can be your r square minus d square equals to 2rr. Okay, now let us analyze the figure. I am taking the figure 1 only. So let this is same as CAD because this is the angle bisector. AD is the angle bisector. This is equal to theta. So I am naming this as P, this perpendicular bisector from I, which is your gives the inner radius R in triangle API. I am applying the trigonometry. PI, this is 90 degree, AI equals to sine theta. So PI is equal to small r, AI is equal to r plus d, this is r and r plus d, this is equal to sine theta. This is equation 1. Next is coming to figure ADC. This is again, it lies on perpendicular bisector. O lies on the perpendicular bisector of BC. So D angle is 90 degree in triangle ODC. In triangle ODC, D angle is 90 degree. Here in theta, and here I forgot to mention that is P angle is your 90 degree. So I can apply the trigonometric ratio again. So it will be CD OD over OC equals to, this angle is theta, here also theta, so DOC equals to twice theta, is equals to your cos 2 theta, cos DOC, or OD equals to R small r plus D, and OC is equal to capital R equals to cos twice theta. This is equation 2. Now from equation 1, small r equals to R plus D into sine theta, and we'll put this, substitute in equation 2. Small r is R plus D plus sine theta plus D equals to R into cos theta. Cos 2 theta is 1 minus twice sine square theta. Or I am getting D into sine theta D equals to R minus 2R sine square theta. Take all this to one side. So this gives me twice R sine square theta plus R plus D sine theta minus R plus D equals to 0. So I am getting a quadratic equation in sine theta. Solving for sine theta, sine theta equals to minus R plus D minus R plus D whole square minus 4 into twice R into minus R plus D whole over 4 times of R. Or sine theta equals to R plus D plus minus, I am expanding, so this will be R square plus D square plus twice RD plus 8R square minus 8RD whole divided by 4R. Or sine theta equals to minus R plus D plus minus 8R square, 8R square, 9R square, . minus 6rd plus d square whole upon mistake, it will be bigger, 4r. Now the sine theta equals to r plus t plus minus, it will be 3r minus d whole square equals to minus r plus t plus minus 3r minus t. Sine theta equals to, there are two values now. One is minus r plus t plus 3r minus t by 4r, or this will be minus r plus t minus 3r minus t. So case 1, between sine theta equals to minus r plus also 2r minus 2d by 2r, 4r, it will be r minus t by 2r. Case 2, sine theta equals to minus 4r plus 0 by 4r, that will be negative 1. So this is impossible. As we took, this is theta, this sine theta cannot be negative 1. This is a, so sine theta equals to, this is the answer. Now we'll get the value of small r in terms of sine theta. This one, theta is equal to r upon r plus t, r minus d over 2, r equals to your let me see again, it will be r equals to r by r plus t. So now cross multiplying, I'll get r square minus d square equals to twice r, or d square is equals to r square minus 2rr, and t equals to square root of r into r minus 2i's r. So this is the application of the Euler's theorem. Thank you for watching. Group